is a very important tool. It has a wide application in almost every branch of science, especially in engineering science. That is, it may be electrical engineering, mechanical engineering, or any types of engineering section. We use the metrics. That is, why we are using metrics is that we can say concisely say that we can develop a smaller concept. Let's say a large number of numbers can be converted into a single object, and then we can do certain number of operations on this single object, thereby say eliminating the need of very large operations. Okay, how can you define a matrix? First of all, how can you define a matrix? Yes, it can be defined based, that is the order. Yes, it is having rows and columns, or I can say that a rectangular array of numbers. Matrix can be defined as a rectangular array of numbers or functions. Depending upon the applications, we may include functions also in this matrix. Okay. Inside brackets, we usually represent inside brackets, right? Yes. For if a writing m by n means, if I am writing a matrix of m by n, where m stands for, yes, m stands for the number of rows, and n stands for the number of columns, right? Agree? So again, if I am writing say a11, a12, etc., a1n. Therefore, n I am writing here. Therefore, how many columns? N columns are there. N columns. These are columns. And if I am writing a21 like this, a31, etc., it may be am1. Therefore, these represents the rows. So these represents the number of rows. Okay. We were writing like this. This can be called as a matrix A of order m by n. A of order m by n. Okay? Clear? Yes. Now, this matrix A can also be written as small letter. Here I am using the elements in the matrix is denoted by Aij, right? Aij. So if I am writing simply a element Aij, that represents the element is in the ith. Can you complete it? The element is in the ith dash and jth. Yes, ith row and jth column. Right. Ith row and jth column. Right. Okay. Now we shall move on to some special types of matrices. First of all, let us see what is meant by a square matrix. Special matrices. First we will see what is meant by a square matrix. Yes, can you give me what is meant by square matrix? What is meant by square matrix? If I am having if I am denoting matrix A of order m by n, yes, that is we can write that m is equal to n. M equal to n. That is number of rows equal to number of columns. Then if I am writing like this 1, 2, 3, minus 1, 0, 3, is it a square matrix? Is it a square matrix? No, because the number of columns here is how much? Number of columns here is how much? Number of columns n is equal to n is equal to 3, right? m is equal to 2. m is equal to 2. For m not equal to n, therefore this is not a square matrix. Therefore, in order to make it a square matrix, what I should do? I should add a column or row. I should add a column or row. Okay, I can, or Muhammad is saying that if I, yes, what I can do in order to make this a square matrix, what I can do? M can be made 3, okay, or n equal to 2. What do you say, Saida? Is it okay? Can we make this a square matrix? First, when we are having m equal to 3 means I need to add one more row, isn't it? I need to add one more row. So if I am writing 2, 1, 4, or if another way of making it a square matrix is I can delete this column, right? If I am deleting this column, this new matrix will be of 2 rows and 2 columns. That also will do. Clear? Okay. So if I am having a matrix, square matrix, 1, 2, 3, say 0, -1, 5, 4, 3, 9. What about this order? It is a square matrix of order. Square matrix of order. Yes, if I am telling that this square matrix, then no need to tell 3 by 3. If I am telling it is a matrix of order 3 by 3, I can tell like that. If it is square matrix, if I am mentioning it is a square matrix, then no need to tell 3 by 3, you can just tell 3. Am I right? Yes. And say if, how can I represent this element? This is A11. What about 5? How can I represent 5 in terms of A? 5 is, yes, A23. What about -1? -1 and 9. -1 is A22 and 9 is A33. And here 1 is A11. Okay. So, what are the specialty of these elements? A11, A22, A33. What is the specialty of these elements? Yes, they are the diagonal elements. They are the diagonal elements of the matrix. And for a square matrix, the sum of these diagonal elements, is known as the trace of the matrix. The sum of diagonal elements is known as trace of the matrix. Okay? Yes, trace of the matrix. Clear? Okay. Now next we shall discuss about diagonal matrix. What can you tell about a diagonal matrix? What can you tell about a diagonal matrix? A diagonal matrix is one in which there is only which elements present? All 0, only diagonal elements is present. All other ones are 0. And should this diagonal matrix a square matrix? Should this diagonal matrix a square matrix? Yes. If it is a square matrix only, we can define a diagonal, isn't it? Therefore, if I am writing 1, 5, 3, 0, 0, 0, 0, 0, 0. Is it a diagonal matrix? Is it a diagonal matrix? Yes. What about the trace of this matrix? What about the trace of this matrix? Yes, trace is nothing but the sum of these things, isn't it? For 1 plus 5 plus 3, therefore it is 9. Sum of diagonal elements. Okay. Now next we will define. So first we have defined square matrix, and next we have defined diagonal matrix, isn't it? So we have seen that this diagonal matrix is a square matrix. Diagonal matrix is a square matrix. Next we will see the third one, that is scalar matrix. That is scalar matrix. Therefore, what should be the criterion? Scalar matrix means if I am writing like this, 2, 2, 2. What will be the specialty of these? What will be the specialty of this type of? Yes, all the diagonal elements should be the same. All the diagonal elements should be the same. So if I am writing like this, Aij equal to 2 for I equal to j. Can I represent this matrix like this? Aij for I equal to j is equal to 2. Am I right? Is this condition representing this matrix? I equal to j means yes. A11, A22, A33, everything are equal and that is equal to 2. Therefore, what is the condition? This scalar matrix, should it be a diagonal matrix? Should it be a diagonal matrix? Yes, it should be a diagonal matrix. And what about diagonal matrix? Diagonal matrix should be a square matrix. I hope you got the link, right? From square to diagonal to scalar, and for diagonal matrix to be a scalar matrix, you can see that all the diagonal elements should be the same. All the diagonal elements should be the same. Therefore, if I am taking 2 outside, what I will get inside? If I am taking 2 outside, what I will get inside? It will be 1, 0, 0, 0, 1, 0, 0, 0, 1. That brings us to the next definition of the matrix known as Yes, this matrix in which all the diagonal elements is unity is known as unit matrix. Unit matrix. Understood? Is known as unit matrix. Is that clear? So can you tell me how can you define a unit matrix of order 2? Unit matrix of order 2. If I am writing like this, Aij equal to 1 for I not equal to j. Is this a unit matrix? Is this a unit matrix? No. What about Raiza? Is it right? If I am writing like this, Aij equal to 1 for I not equal to j. Is it a unit matrix? No, it is not a unit matrix. We can call it a unit matrix only when Aij equal to 1, when I is equal to j, isn't it? When I is equal to j. And what about the other condition? Aij is equal to 0 for I. Can you complete? For I, Aij is equal to 0 for I, yes, not equal to j. Not equal to j. Therefore, the matrix will be like this: 1, 0, 0, 1. Agreed? Okay. Any doubt till here? Is there any doubt till here? Okay, fine. So next one is triangular matrix. Next one we will see what is in the triangular matrix. So a square matrix in which all the elements below the main diagonal are 0, that is known as an upper triangular matrix. A square matrix of a triangular matrix means it is a square matrix in which all the elements below the main diagonal. If I am writing like this, 1, 2, 3, 0, 0, 0, 5, 0, 0. Now, what can I call this matrix? What can I call this matrix? Yes. You can see that this is the main diagonal. All the elements below the main diagonal are 0. Therefore, this is a upper triangular matrix. Got it? This is a upper triangular matrix. If I am writing like this, -3, 2, 7, 0, 0, 4, 0, 5, 8. What type of matrix it is? This is the main diagonal. Yes, main diagonal. And those elements above the main diagonal are 0. Therefore, I can call this is a lower triangular. This is a lower triangular matrix. Yes, lower triangular matrix. Is that clear to you? Okay. Next one is null matrix. Null matrix. For a matrix in which all the elements are, yes, all the elements are 0. All the elements are 0 is known as null matrix. So if I am writing a matrix like this, 0, 0, 0, 0, 0, 0, therefore this is a null matrix of order. This is a null matrix of order. What I can tell? Yes, it is a null matrix of order 2 by 3. Right. Next one is symmetric and skew symmetric matrix. Have you heard of this one? Symmetric and skew symmetric matrix. Yes, what is symmetric matrix? What is symmetric matrix? How can you define symmetric matrix? How can you define symmetric matrix? Anyone? If I can represent, yes, right. A is equal to matrix Ij, then I can say Aij is equal to Aji. Aij is equal to Aji, then it is known as symmetric matrix. Okay, symmetric matrix. That means if I am writing like this, 1, 2, 3, -3, 5, 7. So, can you make it a symmetric matrix? How can I make this a symmetric matrix? What do you have to do for making it a symmetric matrix? Yes, here this is A12. Agreed, Muhammad? Yes. What about 5? What about 5? A13. So according to our definition, A12 should be equal to A21. And I hope this is A21, right? All of you agree? Yes, this is A, second row, first column. Therefore, this should be equal to which value? For making it a symmetric matrix, this one should be equal to, yes, -3, right. Then can both of you tell me what about these two unknowns? Yes, Saida says that it is 5. Yes, right. Yes. And this one is 7. Right. So this, if you are telling, it is 2, 3, and this is 3, 2. Agreed? Clear? Any doubt in this? Is there any doubt? Okay. If you are clear with it, let us move on to next one, that is skew symmetric matrix. Skew symmetric matrix. What will be the condition for skew symmetric matrix? Yes. For symmetric matrix, it was only the magnitude that mattered. Aij was equal to Aji, whereas for skew symmetric matrix, it will be Aij will be equal to minus Aji. Minus Aji. So let us take the same example of A. How can you make it a skew symmetric matrix? These are unknown. Okay, say 1, minus 3, 5, 2, 7, 3. Like this it is there. Yes. Therefore this element will be, yes, you need to multiply the corresponding elements by minus 5. So it will be 3. And what about this one? Yes, this one will be, yes, first one will be minus 5 and this one will be minus 7. Right? Yes. So that is regarding skew symmetric matrix. Skew symmetric matrix. So these are very important. We need to have some proof regarding this skew symmetric and symmetric matrix. So please make sure that you have understood this one. Aij is equal to minus Aji means it is skew symmetric. Symmetric only means Aij is equal to Aji. Okay. Next, we move on to the next part, that is the transpose of a matrix. Transpose of a matrix. And I hope all of you know this one. What is meant by transpose of a matrix? If A is a matrix, I can write A transpose like this, or A dash. A transpose or A dash. Yes, yes. Row changes to column and vice versa. Do you agree with Saida Muhammad? Yes. That is, if I am writing 1, 2, 3, 4, 5, 6, 7, 8, 9. This is A. Can you tell me what is A transpose? In the same order like this. Please fill in the same order. Yes, it will be 1, 4, 7, right? What about the second row? Yes, 2, 5, 8, right? Yes, 3, 6, 9. 3, 6, 9. Right. Therefore, for a symmetric matrix, symmetric matrix means I am writing 1, 5, 3, 5, 4, 3, 1, 4, 3, 1. Then here it will be 4. Here it will be, what about here? 3, and here it is 1. Okay. So this is symmetric matrix. You agree? Now, what about A transpose? What about A transpose? Yes, you can see that it is 1, 4, 3. Then 1, 4, 3. 4 3 1 and 3 1 5. That is same. If A is equal to A transpose is equal to A, then what can you conclude? If you have obtained this relation, that is A transpose is equal to A, then what can you conclude for A? Yes, it is a symmetric matrix. Therefore, what will be the condition for skew symmetric matrix? What will be the condition for skew symmetric matrix? A transpose is equal to, yes, A transpose is equal to minus A. A transpose is equal to minus A. That will be the condition for skew symmetric matrix. Okay, is it clear? Okay, fine. Now, so we have reached up to here. Next one is we need to define the conjugate of a matrix, or we shall give some properties of transpose. Before we move on to the conjugate, we shall see some properties of transpose. Okay, first one, A transpose, the whole transpose. What it will be? First I am reversing it, then once again I am reversing it. A transpose, the whole transpose will be, yes, Muhammad says it's A. Yes, right. It is A. Then, if I am adding two matrices and taking the transpose, first you add two matrices, then I am taking the transpose, that will be equivalent to taking the transpose of each one and then adding it. Did you get me? Yes, if I am having two matrices, first you add that one, therefore you will get a C matrix which is the sum of A and B. Then you take the transpose, that will be equal to, yes, it is a distributive property. Similar is the case with A minus B, the whole transpose. That will be equal to A transpose minus B transpose. Agreed? Okay. Yes. Now, what about if I am multiplying a scalar alpha into A, the whole transpose, that will be equal to alpha into A transpose. Okay. Suppose I am multiplying 2 into a matrix, 3 2 1 like this. Then that will be the same as 2 into A, the whole transpose. If I am taking, that will be equal to 2 separately, I can take it outside, into 3 2 1 4 2 1 3 2 2, that transpose. Clear? Okay. Now next one is AB, the whole transpose. What will be AB, the whole transpose? It will be A transpose into B transpose. Right? Yes, let us check it. Suppose I am taking A is equal to 2 1 3 1. I hope all of you are having the notebook with you. Right? Yes, please note down this question. You have to do it and tell me A 2 1 3 1, B is equal to 1 2 3 4. Okay, I need to multiply AB. How can we do the multiplication? First write one A 2 1 3, 1 into 1, 2, 3, 4. How do you do the multiplication? Is equal to, yes, 2 into 1 plus 1 into 3. Am I right? 2 into 1, 2 into 1 plus 1 into 3. What about the next one? Next element? Next element means 2, 2. 2, 1. 1, 2. Sorry. 1, 2. Therefore, in order to get 1, 2, what you should do? You should multiply first row with, in order to get this element, this is the A12, right? AB, or I can say AB12. This is AB12 element. In order to get AB12, what you should do? You should multiply first row with the second column. Understood? First row with the second column. So first row means 2 into 2. That is 4. 2 into 2 plus, what about next one? Plus 1 into 4. Clear? Is there multiplication clear to you all? Yes, Saida, is it clear? Yes. Next, what about this one? This is AB 2, 1. Therefore, what you should do? You should multiply second row with 2, 1 means second row with first column. Therefore, it will be 3 into 1 plus 1 into 3. And what about the last one? 3 into 2 plus 1 into 4. Therefore, you will get it as AB is equal to, what you will get AB? Please tell, what about AB? 5, 8, 5, 8, 6, 10. Right. Therefore, what about AB transpose? What about AB transpose? 5, 6, 8, 10. Okay. 5, 6, 8, 10. Okay. Next one is to find out A transpose into B transpose, isn't it? A transpose into B transpose. What is A transpose? What is A transpose? A transpose is equal to 2, 1, 3, 1. Yes, B transpose is equal to 1, 2, 3, 4. Yes, have you done? Both of you, have you done it? A transpose into B transpose. Yes, you are getting it as? What you are getting it as? 8, 18, 8, 18, 3, 12. 3, 12. Is it 3, 12 or 3, 7? Is it 3, 12 or 3, 7? Please check. 3, 7. Okay, 3. Okay. Which one is right? Is it 3, 7 or 3, 12? Please check once again. Is either, is it 7? Okay, you are sticking on to 7 and 12. 2 plus 6, 8. 1, 3 plus 4, 7, isn't it? It is 7, right? Yes. So now you see that AB the whole transpose is 5, 6, 8, 10, and A transpose into B transpose is 8, 18, 3, 7. Are they equal? Are they equal? No. So, can you find out the relation? What will be A transpose into B transpose? Can you check B transpose into A transpose? What is B transpose into A transpose? Will A transpose into B transpose equal to B transpose into A transpose? Will A be equal to BA? That is my question. Suppose I am having two numbers, 2 into 3 will be equal to 3 into 2. Am I right? 2 into 3 will be equal to 3 into 2. That is regarding numbers. But for matrix, will it be the same? For matrix, will it be the same? For matrix, we cannot write like this. AB will not be equal to BA. Understood? Okay? So, you just find out B transpose into A transpose. What are you getting? B transpose into A transpose. That is, you need to multiply 1, 3, 2, 4 with 2, 3, 1, 1. 1, 3, 2, 4 with 2, 3, 1, 1. What are you getting? What are you getting? Yes, 5, 10, 5, 10, 8, 10. Is it 5, 10, 8, 10? We are getting 10 here. This is say 1, 2 plus 5, 3 plus 3, 6, 5, 6, isn't it? 5, 6, 8, 10. Are you getting? What about Mohammed? Yes, Saida, is it clear? It is 6. Okay. 1 into 3 plus 3 into 1. That is 6. Understood? Yes, is it clear, Saida? Any doubt regarding that multiplication? See, 1, 3, 2, 4 into 2, 3, 1, 1. Am I right? This is B transpose into A transpose. Am I right? Yes. So, first you can write 1 into 2 plus 3 into 1. That is 5. Second one, 1 into 3 plus 3 into 1. That is 6. 1 into 3, yes. 2 into 2 plus 4. That is 8. 2 into 3 is 6 plus 4, 10. Agreed? Okay. So we have found a relation that AB the whole transpose will be equal to B transpose into A transpose. B transpose into A transpose. Is it clear? Okay. So, next one is regarding complex number. Complex number, we have already studied complex number, isn't it? We have just got an introduction of complex number. X plus iy, where x is the real part and y is the imaginary part. Am I right? We have discussed this, isn't it? Yes. If a is equal to, say, one complex number I am introducing here, instead of real number, I am writing it as complex number. Okay. So, this is a matrix of complex numbers. As we have already mentioned in the definition of matrix, matrix is an array of numbers or it is an array of functions. Therefore, here this can be a complex number also. So, conjugate matrix means it is actually the corresponding complex conjugate. If x plus iy is a complex number, what about the conjugate of this one? How can you find out the conjugate of this complex number? If x, yes, it is x minus iy. Okay, if x plus iy is a complex number, then conjugate is given by x minus iy. Therefore, what will be the conjugate matrix? Conjugate of this matrix A bar. What will be the conjugate of this matrix A bar? Can anyone tell? It will not be minus A. It will not be minus A. Wherever you have a imaginary part, that you should convert it into, yes, minus I. That is 1 minus I, 2 minus 3I. Here you can see, if you have written it as minus A, means it should have been minus 2, isn't it? But is it minus 2? Here there is 0I. Okay, therefore it is 2 itself. Yes, it will be 3I. Did you get the difference between minus A and conjugate of A? Yes, that complex number part should be replaced by minus sign. Okay. Now, the transpose of this conjugate. So, if A is a matrix, A bar means it is conjugate matrix. Okay. The transpose of this conjugate matrix. What will be the transpose of this conjugate matrix? What will be the transpose of this conjugate matrix? 1 minus I, 2 minus 3I, 3I. Am I right? 1 minus I, 2 minus 3I, 3I. So this can be represented by A star. So please listen. First we have written A, then you write A bar. A bar means conjugate. The transpose of conjugate, that is what is meant by A star. Understood? If A is the matrix, the conjugate of A is A bar, where you replace the complex numbers imaginary part with negative sign, and that matrix, the transpose of that matrix, if you take, that is represented by A star. Understood? Is it clear? Okay. So you can see that if I am taking A bar the whole transpose, that will be equal to A transpose the whole bar. That is, if I am taking the conjugate and then taking the transpose, that will be the same as first taking the conjugate and first taking the transpose and then taking the conjugate. Understood? That will not make any difference, isn't it? It will be the same effect. Clear? Yes. Now we are going to define two new matrices based on this concept. Is this clear? Conjugate matrix and A star. Okay. Then you can easily define what is meant by Hermitian and skew Hermitian matrix. Hermitian and skew Hermitian matrix. Okay. So we have already defined A star. A star is equal to, yes, right. A star means A bar the whole transpose, that is equal to A means that is known as Hermitian. Oh, I think we have already studied these things. Is it, Mohammed? Have you studied this one? Yes. Okay. Then you will be able to tell me what is skew Hermitian. What it will be. What is this Q Hermitian? Yes, A star is equal to minus A. A star is equal to minus A. That is what is in this Q Hermitian. For you can see here that if we have already defined about symmetric and skew symmetric, instead of that one, we are not alone taking the transpose of this matrix involving complex numbers, but we are taking the transpose of the conjugate of that matrix. Is that clear to you? Yes. Okay. Next one is a row and column matrix. A row and column matrix. Row vector or row matrix means it is having only one row and any number of columns. One row matrix means only one row. 2, 3, 4, 5. Here, what about the number of rows? What about the number of rows? 1. What about the number of columns? What about the number of columns? 4. If I am writing like this 1, 3, 5, 4, 3 like this, what can you call this matrix? What can you call this matrix? Yes, it is a column matrix. The number of columns is 1. Right? Yes. So what about the number of rows? What about the number of rows? 5. Isn't it 5? Yes, because this is a row matrix and column matrix. Okay. And what about equal matrix? When you can tell the matrix are equal? What about the order? What about the order of the matrix? Should they be the same? Yes, is it necessary that m equal to n? Is it necessary that m equal to n? If I am writing 1, 2, 3, 5, 6, 8. Okay, this is A. And B is equal to 1, 2, 3, 5, 6, 8. Is m equal to n here? Is m equal to n here? No, it is not necessary that it should be a square matrix. M equal to n means it is a condition for square matrix, isn't it? If A and B are equal, if I am to say that A and B are equal, then I can say that order of A and order of B should be the same. That is m by n, m1 by n1 should be equal to m2 by n2. Am I right? m1 by n1 should be equal to m2 by n2. And what about the corresponding elements? What about the corresponding elements in the matrix? The corresponding elements also should be equal. Corresponding elements also should be equal. Clear? Okay, I think we can take a 5-minute break. In that meantime, you please calculate this one. You please find this one. Find B transpose into A. Okay, can you do? Find B transpose into A. Yes. Yes. Okay, so you have got the answer 21, 10, 6, 24, 4, 5, 9, 8, 4. Okay, did you use calculator to do this? Did you use calculator to do this? No, okay. And do you know how to do it with the help of calculator? Yes. What about Mohammed? Do you have? Are you having a calculator with you? Are you having a calculator with you? Yes. Which one? 991 ES or MS? Which one? Which model? 100 MS. Okay. So I think it may not be available in 100 MS. Yes, in 991 ES it is available. Are you having any shift operation metrics there, Mohammed? Are you, is it showing any metrics in your keys? Say most probably it may be 4 or 5. Above that one, it is it written metrics? It's either I think it may be 4 in your case, right? Yes. Okay, Mohammed, it may be difficult for me to teach with the help of this 100 ms because I don't think it is available in that type of calculator. Okay, so you just go for this 991 ES. It might be useful for you if you are going to do much higher calculations. You can easily take the help of the calculator. So I think we can discuss that in the next session. Okay. Hope you will have that calculator by that time. Okay, fine. So moving on, we can see next thing, that is regarding the rank of a matrix and also some matrix operations. Matrix operations. Now, if you are having, if you are having a matrix A and B, then it is not necessary that AB is equal to B, or I can say that AB is not equal to BA. AB is not equal to BA. And if A is a square matrix, and if it is found that A square is equal to A, that is, if you multiply A with A and still if you are getting A, then you can call it as idempotent. The matrix as idempotent. Okay? If A square is equal to A, then the matrix is known as idempotent. Okay. Now, orthogonal matrix means orthogonal matrix. Next, we need to define orthogonal matrix. Orthogonal matrix refers to those matrices if the condition A transpose is equal to A transpose into A is equal to I is satisfied. What is this I? What is this I referring to? What is this I referring to? Unit matrix, right? Unit matrix. If A transpose is equal to A transpose A is equal to I, then we can call that matrix as orthogonal matrix. Orthogonal matrix. Is it clear? Saida and Mohammed? So if you please do this one, if A is equal to cos theta minus sin theta cos theta, show that this is orthogonal. Show that this is orthogonal. what you have to do? Can you check whether this is orthogonal? To check whether it is orthogonal, what is the condition? What is the condition? What you have to find out first? You have to find out A transpose, isn't it? You have to write down A transpose, then you have to find out the product A into A transpose. A into A transpose. Right? And this should be equal to, this should be coming equal to, if it is becoming equal to I, yes, I, then you can say that is orthogonal. Can you check? Can you check? Yes, 1001. Mohammed is getting yes, 1001. That means, what is this one? This one is a unit matrix. What about the order? What about the order? Of order 2. Unit matrix of order 2. Right. Okay. Now, a unitary matrix means, what is meant by unitary matrix? A unitary matrix means, if A into A star is equal to A star into A is equal to I. What is A star? What is A star? Regarding which matrix it is? Is it real matrix or complex matrix? Complex is conjugate. The transpose of the conjugate matrix, isn't it? The transpose of the conjugate matrix. For A into A star is equal to A star into A, then we can call that it is unitary matrix. It is unitary matrix. Okay. Okay. Yes, what is the question? Yes. What is the question? Y is equal to e raised to y is equal to e sine inverse x. Yes. So that yn x equal to 0 equal to n minus 2. Okay, I understood your difficulty. Okay, you can just send me the through that mail. Okay, you just take the photo of that one and send me through the mail. We shall discuss in the next class. Okay, which is the question number? Can you just tell me the question number? I can also refer through that one. Winter 2012. Okay, winter 2012. Which one? Question number? Question number 1. Okay, I shall see to it. Yes, I shall see to it and let you know. Okay. So from next class onwards, I think we need to have some more extra classes from next week onwards that I shall inform you through mail. Okay. And also, there will be a test based on portions which we have covered till now. 1 hour before the class, that is 7 o'clock, your class begins. You will be getting a question paper at 6 o'clock. Okay, you will be getting a question paper at 6 o'clock. You please do attend it and send me the answers through my mail. Just email your answers. Okay, otherwise you will not be studying. That's why. Okay then. See you next class. We shall cover metrics by the next mail ID. Okay, 1 minute. At amistudy.com. This is the mail ID. Okay then, see you next class. We shall discuss completely the metrics portion and cover it by next class. Right. Yes, on Friday. On next Friday, that is 17th. Okay then, good night.